circles and two circles, one at the top and one at the bottom. So to wrap the cylinder, cover it, laterally, just cover its sides without, including the circles. We would need a rectangular sheet of paper, right? To use When we use this rectangular sheet of paper, the length here, this is the length and this is the width, right? Over here, what usually that this is going to be the height of the cylinder, right? So to remember these formulas, you will need to understand how you're going to wrap them. That is one better way to understand it. So this width is going to become the height. So when you wrap this paper across this cylinder, what happens here is that the length will become the circumference of this circle and the circle at the bottom, right? And then this height would become this particular height, meaning the width of the rectangular paper would become the width of the height of the cylinder, right? And the surface area of the cylinder is coming out from the rectangular piece of paper is covering the cylinder, and that is becoming the surface area. So basically the is area of rectangle is equal to surface area of cylinder, right? This is very practical and uh, very logical to see here. So what is the area of a rectangle here? This is length into breadth, length into width, right? But when it is being wrapped onto a uh, cylinder, the length and width are becoming two different things. The length is becoming the circumference, right? So circumference of the circle, and the width is becoming height of the cylinder, right? So the surface area of a cylinder would become circumference of a circle into height. So what is the circumference of a circle's formula? 2 pi r,
Yeah.
2 pi r into h, right? So this is the surface area of a cylinder, right?
Yeah.
This Right, this is the formula for surface area of a cylinder, right? Now to calculate total area of a circle, all right, we have Hani and Yashandi also with us. Okay, so guys, we were discussing surface area and volume. We started with that, and we agreed to start with understanding how we would remember the formulas. Okay, so that is what we were doing. So we started with cylinder here, just a quick recap. So a cylinder is basically a figure with two circles, one at the top and one at the bottom, and a height, right? So what we are doing here is we are looking at surface areas and total surface areas of these figures and how we will remember the formulas if we can't recall them. So surface area of a cylinder is basically uh, measured by wrapping rectangular sheet of paper across the cylinder, right? If you have a chips bottle which is in the shape of a cylinder, those bottles are wrapped with a piece of rectangular sheet, and the rectangular sheet has length and width. Okay, so what happens when we wrap this paper across this cylinder is that the length of the paper would become the circumference of the circle. Okay, and the height of the cylinder, meaning the width of the paper, would become the height of the cylinder. So basically what is happening is that if we can calculate the area of the rectangle, we would be able to calculate the surface area of the cylinder too, right? So in short, what's the conclusion here is that the area of the rectangle is the surface area of the cylinder. All right, so area of the rectangle is length into width. That's pretty simple, we all know that. But how will that translate into surface area of the cylinder? So what will happen here is that the length will translate into the circumference of the circle and the width will translate into height. Okay, so circumference of the circle is going to be 2 pi r into h, okay, which is the surface area of a cylinder. All right, now what happens when we talk about total surface area? Total surface area. So total surface area is basically when we are also going to cover the top and bottom of the cylinder, right? So the top has a circle, the bottom has a circle. And what is the area of a circle? So if we have to cover the circular regions of the cylinder with a piece of paper, again, we'll have to know what's the area of that particular piece of paper. Okay, so the lateral surface area that is there, that is the surface area. This is going to be part of the total surface area. Plus, we will also add two circular regions. Okay, this is circular region 1, circular region 2. We will add the areas of these two circular regions also to combine the total surface area of a cylinder. So since we have two circular regions, the circular region area is basically area of a circle, which is pi r square. Since we have two circles here to cover, we will be including both of them. Okay, so this would be 2 pi rh plus 2 pi r square. So the answer is this, that is what we remember, right? Total surface area. If you forget, you can recall it in this way. Okay, is this clear? Right? Okay, so since okay, Zab hasn't joined yet. All right, Yasindi, how is surface area and volume a chapter for you? Is it a difficult chapter? Is it a lengthy chapter? I was asking everyone about it.
It's okay.
It's okay. What's the most problematic part about that chapter? Is it the last exercise, combination of solids when we are calculating the volume, or the surface area part? Which one
Uh,
is
I haven't reached there yet in school.
you? Acha, you have that chapter left, right? You have not completed the chapter, right? Okay. What about you, Hani? Did you complete this chapter at school earlier, or is it pending?
Yeah, we completed it.
All right. And how did you find it? What was the most confusing part, or how did you find it before the completion, after the completion?
Yeah, that combination of volumes and surface areas together.
Okay, so that's
That's
confusing.
kind of confusing. Yeah.
Okay, all right. So when we discuss this particular thing, I hope that would clear some amount of the confusion. Okay, and then solving the questions is the real way to then clear the whole confusion there. Okay, so cylinder. What else do we discuss here? And then we discuss when sorry, then volume of a cylinder. Okay, volume of a cylinder. So what is volume of a cylinder? Uh, what's the formula for volume of a cylinder? Is it pi r square h?
IRL.
Yes.
Pi r square h, right? Or what is it, guys? Let me just Google it.
The pi
Is
r
it
square is circle, h is height, so pi r square.
right? It's that's the height, right? Volume of a cylinder, pi r square h. Yeah, pi r square h. So basically what we are doing here is that we are taking the circular regions, two circular regions, since volume is going to occupy volume, basically any amount of gas, liquid, or solid that is going to occupy the space inside it. So we have two circular regions, and that's the funny part about this chapter is to distinguish this you know silver lining between surface area and volume is that when we are calculating the volume, we won't add two circles separately. Okay, over here when we were calculating total surface area, we were considering two different circles, right? We were considering circle 1 separately, circle 2 separately too, right? And this is the confusion I think that happens a lot of times, is that should we add the volume, should we take the area of the circle twice, or should we take it once? Should we take the volume of a circle once or twice? Okay, so that's the part that you need to get clear about, is that when we are calculating surface area, each and every surface is going to be added individually. Okay, when we are adding that, or if we are stacking up different solids on top of each other, or mixing them, or combining them, or working with them, surface area will always very explicitly look at how much of the surface area of that particular shape is being included. If we on this piece of, let's imagine this piece of paper. This is a rectangular sheet, which is length into height, length into width. That is a rectangular sheet. Now, if I place a cup, or let's just say a hemisphere. Okay, a hemisphere is placed on top of this. Okay. Now, if I need to calculate the area that this hemisphere is taking on this piece of paper, what will I do? I will calculate the area of rectangle minus surface area surface area of hemisphere. That is what I will do. This is how you will do it. So over here, this will get clear as you do the questions, but this is one distinction that you should remember, that when you're calculating volumes of, different combination of solids, you will throw in the volumes of both the, whatever the solid you are including. Okay. If you have a bottle with you like this, if you have this bottle, to calculate the volume of this bottle, what you will, the confusion that will arise is that, will you take, if we imagine that this particular cap was of the same radius as the bottle's radius. Okay. If we had a cylinder, on top of the cylinder there's another cap which is exactly in the shape of the cylinder's radius. Okay. So to calculate the total volume of the cylinder now, if we were given the radius of the bottle, you will take, you will add the you will add the volume of the cylinder plus volume of cylinder plus volume of the cap. Okay. You would do this with that, but in surface areas you won't do that. You would be very explicit about what you are adding, what you are exempting there. Okay. It will get clear as we do it. Okay. But that's the thing, when you're calculating volumes, throw everything in. If you're calculating the volume, okay, calculate, add it. That's the simple trick there, add it. Okay. Apart from cylinder, what else is there? Cone, right circular cone.
Yeah.
Right circular cone is a tricky part. Okay, so a right circular cone. Right circular cone has a few things. There's slant height, right? There's slant height, and then there's radius. Then there is height, right? There are three components to this. So now where the hell do these things come from? So right circular cone can be generated by a right angle triangle. Okay. In this right angle triangle, this particular base is going to act as the radius. That is how we are going to get the radius of a right circular cone. Okay. And then the height of this particular triangle, right angle triangle, the perpendicular height is going to be the height of the right circular cone. And then the uh, slant height, meaning the hypotenuse, is going to be our slant height. Okay. Now, if we attach a stick to it and rotate it, this particular figure would become this. Okay. So over here, this is our radius. Okay. This is our height. That is very clear. And this is our slant height. Okay. Now the relation between slant height, radius and height is basically this, right? L is equals to root over r square plus h square. This is basically coming from the right angle triangle that is being formed. That is, the elementary figure that is inside the right circular cone. So basically L square is equals to r square plus h square is nothing but the right triangle that we have. Okay. And this is why we have this particular component to it. Okay. So when we are calculating the surface area of a right circular cone, okay, we have surface area and then total surface area too, right? So total surface area and surface area, the difference here is going to be that the total surface area is going to involve the circular region on top that is being formed here, right? Now what about surface area? Now surface area, now, how is this surface area related to the right angle triangle? So basically, a right angle triangle is becoming a right circular cone. So over here, we are going to use the area of a triangle. Area of triangle is equals to surface area of cone. Okay. So what is the area of a triangle? That is half into base into height, right? This is the surface area of cone that is becoming the case. It's the same way we looked at a cylinder case, right? So over here, what is becoming base? What is becoming height? Okay. So over here, the radius is over here, the base, which is the radius, right? So this particular thing, radius, now here the confusion, this particular height is not the perpendicular height that we are concerned with. Okay. This particular height is actually going to be the slant height because we are talking about the surface area. Okay. This height is actually going to be the radius, is going to be the place where the stick is going to be held. Okay. And that is going to be the depth of the cone. Okay. So that particular height is not the height that we are concerned with. The lateral surface area or the surface area is going to be the region that you can touch, not you can, dive your hand into the cone. Okay. So this is going to be one, thing that we are going to change, that the surface area is going to involve the lateral surface area. So that is why the slant height will get involved here. So a lot of times you notice that you are not given the height, you're not given the slant height directly, you're given the radius and height and you're told to find the surface area and you find it. Okay. So basically the slant height is going to become the height, and then the base is going to become a circle. Okay, so over here the base is going to become a circle. So surface area of a circle is circumference basically. So this base is going to become the circumference, that is going to become 2 pi r into L. Okay, this 2 and 2 get cancelled out, and this is how we get surface area of a cone. Okay, understanding this is necessary sometimes, because in questions where you get stuck, this is how you can remember, okay, this is how I got the answer. Okay, so this is how we get pi RL. Now when we think about total surface area is going to be lateral surface area plus area of the circle that is on the top, right? Area of the circle. So this is going to be pi RL plus pi r square, since we only have one circular region here. So we are familiar with this. This is R plus L, right? So is this clear? Right circular cone? All
Yes.
right. Now let's move to the volume of this cone. Volume of cone. Okay. Okay, that's good. That's good that you guys are following this. So volume of a cone now, what happens when we calculate the volume of a cone here is that there's a neat little diagram from 9th standard surface area and volume, and that is how I also learned the formulas. What they did there is basically they took a cylinder of height h. Okay, a cylinder of height h. And what they did is they took a cone with the dimensions that we just decided. Okay, the standard dimension, height, radius, length, and height. Okay, all of these things. What they did is that they started to fill up this cone and pour water into this particular cylinder. So in the figure there, what happened is that to fill this particular cylinder of height h, this is different height h. Okay, this is different height d. What happened there is that it took three parts of three attempts of three full cones to fill up one whole cylinder. Okay, so what is happening here? No, this is the same height, to be honest, the same height. Cylinder and the cone are of the same height. Okay, the depth of both the figures is same, but the volume is going to be different here because of the radius and other things, right? Or okay, so the radius and the height are going to be same. Radius and height are same for cone and cylinder. Okay, so what happened there is that we filled three cones, three full cones were needed to completely fill the volume of the cylinder. So since we already have very easily deciphered the formula for the volume of a cylinder, and we can see that there's a relation here that three cups, three units of cone, 3 units of cone's volume can be uh, can be used to fill up one cone of one cylinder. Oh my God, I need to do something about my speech today. All right, so the relation here is three volumes. 3 times volume of cone is equals to 1 volume of cylinder. Okay, we know the volume of cylinder, that is pi r square h. And over here, we can say that volume of cone will be 1 by 3 pi r square h. Okay, this is how we'll get the volume of cone. Okay, so this is the relation between this. Now let's move to the other figure, that is sphere. So sphere's case is going to be something that we cannot really explain it completely. Surface area or total surface area. There is no two things here. A sphere only has one surface. There are no two surfaces, total surface or lateral surface. So the surface area of a sphere is going to be 4 by 3 pi r square. Is that, or pi r cube?
4 by 4 pi r क्या है?
4 pi r square. That, this is the
Yeah.
volume, right?
4 by 3 pi r cube is volume.
Volume, right, exactly. Okay. 4 pi r square. Okay. Now hemisphere is going to be half of it. So the surface area for hemisphere is going to be half of that. So 2 pi r square. Okay. Now a hemisphere will have two surfaces, right? A surface, lateral surface, curved surface, okay, curved surface area, and then a total surface area where this one circle is going to be involved. Okay, so total TSA of a hemisphere would be 2 pi r square plus the area of the circle. Okay, so that is how you get 3 pi r square. Okay, now volume of this particular sphere is going to be 4 by 3 pi r square, pi r cube, and a sphere's volume is going to be half of that, so that is going to be hemisphere, that is going to be 2 by 3 pi r cube. Okay, these two figures you need to remember them. uh, Not very intuitive ways to remember them except just remembering them. Now we have cube, cuboid, and right, we are just left with cube and cuboid. So cube is basically made up of a square made up of six squares, right? When we make a cube here, okay, so when we are making this particular uh, cube, since it's made up of a square, all the squares are going to be of the same side length a, right? This is going to be the side length, right? But how many faces does this cube has? This is going to be your face one, the front and back, and then there are going to be two surfaces, top and bottom, and then two lateral, 5 and 6, right? So to calculate the surface area of a cube, we are going to add the areas of six squares, right? So the area of square is a cube, a square. And since we have six squares here, so to cover this whole cube by a wrapping paper or a gift paper, if we are trying to understand it that way, we will be calculating the area of six squares, six individual squares. So the area of a cube would be 6a square in this way. Okay. And similarly, volume of a cube is 6a cube, right? Or is it? No, it's just a cube. Why is it a cube? We can understand that intuitively because volume, since it's a cube, all the sides are going to be of the same length, right? Same value. So over here, this component is the height of the square, height of the cube. This is the height, this is the length, and this is the width, right? So to calculate the volume, we will have to include the component of the height, right? That is how we introduce volume into the equation. So volume of a cube would be at multiplying that particular side length into the area of the square, which will give us a cube, right? This is how you will get a cube here. Okay. And if we are not going to calculate, if you are going to customize this formula, to tweak it according to our needs, then area of this particular cube is going to be very easy, right? Since all the sides are of the same length, if you're going to not wrap the cube top and bottom, then you can just remove two and this would become a square. If you're just wrapping one side, then it would just be a square. So square is basically very simple. Now cuboid is going to be a tricky part where if you understand the notations and the figure, then it would be easy. Nothing too complicated about this either. Okay, this is made up of two rectangles. Okay, so a rectangle is basically length and breadth, right? Let's make this first. All right, so length and breadth. So instead of this becoming breadth, we can say that this is becoming height now. And we can say this is breadth and this is length, right? So we have, since rectangle is a figure which has opposite sides as equal, right? So we have six rectangles here, right? What we can notice here is that the first rectangle is going to be this particular region. And okay, this is not really going to help, highlighting it. Okay, since we have rectangles here, let us imagine the rectangle that is at the back of the back rectangle and the front rectangle. Okay, these two rectangles are going to be, if we are going to calculate the area of these two rectangles, the area of these two rectangles is going to be 2 times, can you see that it's h into b? Is this visible that the front and back rectangular area is going to be calculated by 2 into h into b, meaning there are two rectangles, that is why we are multiplying 2 here, but the region here is that this length and this height. Okay, let me write it down, then you can see. Then there are two rectangles that are same laterally. Okay, so if laterally we are calculating, that would be 2 times h into l, right? And then there are two rectangles on the top and bottom. Okay, so on top and bottom, if we have the same rectangles, that would be, what would the dimensions of that be? 2 times 2 times this is going to be breadth, and this is going to be b into l. Okay, let me know if you guys understand this. If someone did not understand it, let me know. We will just go through it. Everyone understood this?
Yes.
Yep. All right. Okay. So basically, this is going to be your surface area. All right. It's good that you understood, everyone. Um, all right. Okay. So this is going to be a surface area. Okay. And volume is going to be pretty much simple. LBH. Okay. All right. So this is it. All right. Let's take up some questions from last exercise involving volume. Does anyone have any doubts in the gulab jamun question? Or did you find it confusing? Anyone? It could be anyone. It's all right if you don't have, but let's take the gulab jamun question. It's interesting to do. All right. So over here, we are being told that a gulab jamun, the one piece of gulab jamun, okay, individual gulab jamun, contains sugar syrup up to about 30% of its volume. Okay. So volume of gulab jamun, meaning 30%. 30% of volume of gulab jamun is equal to sugar syrup. Okay. Syrup. Now we are being told this is given to us. Find approximately how much syrup would be found in 45 gulab jamuns. Okay, so this is the relation between one gulab jamuns, so sugar syrup and this. Okay, I have a list, so don't mind that. So 45 gulab jamuns. Okay, 45 gulab jamuns. So the shape that is given to us is hemispherical with two ends. Okay, a cylinder with hemispherical ends. So over here, the length and diameter is given to us, and so height or length is 5 centimeters and diameter is going to be 2.8 centimeters. Okay, right. Now we are being asked to find the volume and what is going to be the volume of 45 gulab jamuns. Okay, how much syrup is there in 45 gulab jamun? So to find the volume of gulab jamun, over here we are going to add the volume of cylinder plus 2 times of volume of hemispheres. Okay, so over here the volume of cylinder would be pi r square into phi, or the much better way to do these questions is to sort of try to substitute the formulas first, and then 2 times of volume of a hemisphere is 2 pi r cube, right? So try to take out the pi r and whatever values you can here. So 2 pi r square, you can take out this. So h plus 4 by 3 r. Okay, this is much easier to solve, and a lot of times what I have observed is that if you substitute and calculate it, it is going to come out, for some reason the answers are going to be wrong, because a lot of times the pi is not given to us as 3.4 or 22 by 7. So because of this approximation, the answers are deviating from the correct answer. So it's much better to take out the pi r values as much as possible. Okay, so over here it is not given to us what to be used. What do we use pi as when it is not given? Is it 22 by 7 or 3.14? What do we use generally? Anyone?
Yes,
Which one do we use? That I don't remember it.
22/7.
22 by 7. Okay, let's use that. So 22 by 7 into the radius is 2.8 whole square plus the height is 5 plus 4 into 2.8. So this would be 22 by 7 into 4
Sir,
into, yeah, anything? Yeah, Umar?
this is 1.4, sir.
3.14. That is what we take.
No, radius is 1.4.
Radius is 1.4. Oh, we are taking diameter. Oh, sorry. Right. Thank you for that correction. 4.1.4 whole square. This is going to be 1.4. So 22 by 7 into 1.4 whole square into 5 plus this would be 6.4. 4 by 3, right? 4 by 3. So this would be 22 by into 0 0.2 into 1.4 into 5 plus 6.43. Okay, so you will find the volume of gulab jamun through this particular whole calculation, and then you would take 30% into volume. That would give you these sugar syrups volume. Okay, and you would multiply this with 45 and you would get the answer. All right, is this clear? Is this one clear?
Yeah.
Yeah. Let's take the next cuboidal stand problem and then the one below it. If you have any particular specific questions in this chapter that are troublesome, let me know. We will take that up too whenever the chapter is completed at school for you, Yasandi, and then anything for you, Saad and Ahani also. Okay, if since you guys have completed the questions already, chapter. Okay, so let's talk about question number 4. We are being told that a pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. Okay, so first of all, the pen stand is made out of a cuboid. Okay, after making this cuboid, we are making time conical depressions in it. Okay, so we are taking out some amount of wood out of the cuboid, and in place of that wood we are making conical depressions, and in that we are holding pens. Okay, so the dimensions of the cuboid are given to us, that it is 15 centimeters, 10 centimeters, length into breadth into height, length into width into height. So 15, 10 and 3.5, length, width and height. Okay, the radius of each depression is 0.5 centimeters and depth is height is 1.4 centimeters. Find the volume of wood in the entire stand. Okay, so now we need to calculate the volume of wood in the entire stand. So over here we will have to calculate the volume of the complete volume of the stand. Stand in the sense the stand which has the conical depressions. Okay, or else we will not call it a stand. It is a pen stand, right? So that's one thing that is clear. So volume of cuboid minus volume of conical depressions. Okay, as simple as that. This question is as simple as that. Okay, so this is it. You can calculate it and you can minus it and you'll get the volume of the entire volume of wood in the entire stand. This would give you the complete volume of the cuboid, which is in the shape wood block, which is in the shape of a cuboid, and then the conical depressions through which we took out the amount of wood. Okay, is this question clear?
Yes, sir.
All right. So the next question is, a vessel is in the form of an inverted cone. So we are talking about a cone, inverted vessel, which is in the form of a cone. So the height of this cone is 8 centimeters, and radius of its top, radius of cone is 5 centimeters. All right. So it is filled with water up to the brim. When lead shots, each of which is a spear. So radius of spear, lead shots is 0.5 centimeters, are dropped into the vessel. Okay, so when lead shots, certain number of lead shots are dropped into the vessel filled with water up to the brim, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. All right, so this is a loaded question a little bit, but very basic. Just a second, let me take a phone call. Sorry about that. All right, so over here we are being told that certain number of lead shots were dropped inside a vessel of a cone shape, and when that happened, 1/4 of the water was flown out, meaning when lead shots were dropped in, dropped 1/4 volume of cone or water was flown out. Okay, so we need to find the number of lead shots. So if you follow this reasoning here, what you can do is make a relationship between it, very basic relationship. So what we will do here is that volume of one lead shot. Okay, well, we need to find the number of lead shots. So we have the radius of the spear of the lead shots. We can find the volume of lead shots here. All right, this would give us the volume of lead shots. Now volume of cone divided by, okay, so over here volume of cone divided by 1/4 divided by of volume of spear. This would give you number of lead shots. Volume of cone divided by volume of spear. Right? Because if you divide the whole volume, the amount of volume that was leaving the vessel, that is 1/4 of the volume that is leaving the vessel divided by one single lead shots volume, that would give you the complete volume, complete number of lead shots. Because if you multiply this over here into this volume of spear into number of lead shots, this would give you 1/4 the volume of cone. Right? That is the relationship. Right? Is that making sense? Is it making sense, everyone? Hani? Yasindi? Anyone? Umair? Is it making sense that this is how we'll find the number of lead shots? Umair
Yes, sir.
and I did this question काफी time pehle. Yeah, Hani, you were saying something?
No, yeah,
Oh, yes.
I
It's
get
I
making
it.
said yes.
all right. Okay. So when you're solving these kind of questions over here, we won't substitute the values right away. Okay. Don't do that mistakes. I did that once a few days ago when solving this question. Instead of that, try to, eliminate as much as pi and r possible. Over here, radius of cone and radius of the sphere is different, right? So let's not confuse them, write it separately, R1 and R2. Okay. Over here, you can eliminate pi and pi, right? And what about 4, 1 by 4 into this? So this would be 1 by 4, this, and then let me write this over here. Pi into, we eliminated pi, right? So that would be R1 square into H divided by 4, and this would be 4R2 3 divided by 3. So this would give us R1 square H by 4 into 3 by 4 into R2 cube. Okay. So this is going to be our relation. And what was R1 here? The radius of cone was 5 centimeters. Okay. So 5 whole square into the height was 8 centimeters. Okay. 8 divided by 4 into 4 is 16 into what was the radius of the spear shots? Um, 0.5. Right. All right. So solving this would give you the answer very easily. Okay. Just do that. Don't do that mistake of, trying to insert pi and calculating along with it. Eliminate pi as much as possible from the questions. Okay. So this was a question that many of us found confusing last time. Okay. So take up this chapter, bring your questions from it, okay? Or else the classes would feel dull if you guys do not interact here with me or, ask cross question or, don't do that. And of course, exams are near. So if you bring your doubts, that would be much better. That would help you do it properly. Make a note of our classes separately and the doubts that you're getting cleared here. Okay. And don't feel shy about, speaking out if you have any doubts. All right. So we can call this chapter completed if you guys do not have any doubts, and I would give you a day again. In the next class, you can bring your doubts from this chapter, from any exercise or any other doubt from, case studies or anything like that. But bring it because today's class felt very dull. It felt like we did not talk much, and I was the only one, taking up questions from my own side. Okay. Because if you guys do not have any doubts, then we can skip a chapter like we did with areas related to circle, and you still have time to bring your doubts from areas related to circle too. Okay. So let's not make these classes unproductive, okay, and spend time solving questions which you can also solve, okay, or clear doubts that you can also clear yourself. Okay. So next class is going to be on Tuesday. So areas related to circle and yeah, surface area and volume. And I'm emphasizing this again and again to be engaging in the classes because your parents will need to have some kind of a, report that what our kids are doing in the class, right? How are they doing? How are they performing? So if you just stay mum here, that would be difficult for me to, give them some kind of, feedback. And I'm also a student. I'm not a, very old guy, teaching you guys here. So I'm also a student, so I understand that it's not really easy to open up on online classes. So it's all right, but take your doubts out, bring your doubts, and let's solve them. Okay, because without that, I cannot give any feedback, which is being asked of me to give of you guys in the class here. Okay, so I hope you understand that. So be active in the classes, in the next classes that are coming up. Okay, since board exams are here. And also Yasindi and Hani, one important thing for you guys is that I am not going to be available on 28 and I'm not going to be available on 29th. Okay. So it's very crucial for you guys to ask your doubts, before your exam, before 29th. Okay. Before 28th. All right. Because I have a family wedding then. So I won't be available on 29th. I can't really make time for that. So I have told the team to schedule any extra classes if you guys have any doubts regarding your chapters and if we want to conduct an extra class. So I'm giving you that, free hand to schedule a free extra class if you guys want to, or before the exam. So don't feel like कि एक दिन पहले पूछ लेंगे सारे doubts, or you would just utilize the last day to ask your doubts before the exam. Okay, that's not going to happen, and that's not going to turn out well for the pre-board also. And yeah, that's one thing that you need to know. And Umer, please help me out with your date. Did your father share the pre-board date?
Wait, let me check.
Just check it and then we can end the class. If uh, you guys do not have any doubts personally to resolve, all right, you can leave the class now. It's almost time. Just remember the next class, bring your doubts, be active, ask doubts. If you do not have, then we can skip the chapter. Okay, but we
It
can
is
take
on
it up again.
4th December.
It is on 4th December. Okay. Saad, buddy, you also give me a date. Try to find out the date. I believe they would have given you a date. They should give you a
I
date.
don't know. School didn't provided it.
Yeah, yeah, I know. You did tell me that, but try to ask your teachers tomorrow. It's right whenever you find the time. And yeah, Yasindi and Hani, do remember it that I won't be available on 29th for any doubt resolution. Okay. So actively bring your doubts. And Hani, you do have a lot of chapters that you did not properly attend lectures for at school. So have a notebook, track down your doubts, and let's work on them. Okay. Or else it's going to get difficult. And look at the timetable also. Not timetable in the sense that we have classes on Tuesdays, Saturday, and our classes are on Tuesday, Thursday, and Saturday, right? So according to that, calculate how many classes we have left. I do that on my end, and you guys also do that so that you don't lose track of time and forget to resolve whatever doubts you have or problems you have. Okay. So let's end the class here. If you do not have anything to add, we can end it here. Okay, Saad, you can stay. I will be here. Okay. If Umair, Yasindi, and Hani, you can leave if you do not have anything, okay, to ask me later on. Okay, Saad is going to stay. So, all right.
Thank you, sir.
You're welcome. Take care. Bye bye, Yasindi. All right, Saad, what's up?
Yes, sir.
Yep, what's up, Saad? What is up? What do you want to talk about?
Sir, I was asking that after the after how many chapter will we have the revision from first chapter?
So, how many chapters will we have a revision from first chapter? Okay. So last time when we started our batch here, we decided to start with geometry, right? So once
Mm.
this chapter areas related to surface areas and volume is done, uh,
Uh,
what we can do is we can start with start from the starting, in the sense which chapters are you looking forward to revise? Like which chapters are you do you want to revise? Tell me that, because
all the chapters like
all the
revision,
chapters
late revision.
revision.
Yes, sir.
Okay, from the beginning.
Yes.
Okay, so not any specific chapter that you want to revise right now,
No, sir.
but
All
in
the
general,
chapters.
all the chapters.
So,
Okay,
sir, how will it be if I take one-to-one tuition? Like one to
we can we can do that. You can talk to the team there. I'm fine with the time. I am
what time can you
available.
give me?
What
Like what time?
time? Generally, I am available from 7:30 to 11:30 right now. Okay.
Mm.
I can push back my time a little earlier too, from 6:30 to 11:30 India time. That is what I'm telling you, India time. Okay. So from
Mhm.
India time, 6:30 to 11:30, I'm available generally. And if you are going to schedule one-to-one classes, then you can definitely talk to the mm, academic team once.
What
They
time
will.
it will be in UAE? What time it will be in UAE?
What time?
Like
UAE is 1.5 hours ahead, behind, right?
ahead, ahead
Okay,
or behind?
behind. In uh, UAE is in UAE is 1.5 hours behind. So right now it's 9 o'clock for you and it's 10:30 for me. Okay.
Okay,
So
okay.
if you when do you come back from school? When do you come back?
Yes, sir.
When do you come back from school? At what time are you back home?
At school,
Hmm.
I have extra classes till 4 o'clock.
4 o'clock.
Yeah.
Okay, so
Yes.
4 o'clock meaning uh, if it's 4 o'clock for you there, then it would be 6:30 for
7
me.
of UAE.
5:30. Yeah, if you come, meaning you come back at 4, that would be 5:30 for me, 5:30 Indian time. So when will you be comfortable with the first class? Like, what is the earliest time that you can attend the class?
7
7 o'clock. Okay, 7 o'clock for you. That would be
or
8:30.
6:30.
Okay, so if it is 7, see, I can give you a time that I am fine with 6:30 to 11:30. Okay, right now not 6:30, 7:30 to 11:30. Okay, so 11:30
Mhm.
to 10, 11. Just a moment, let me just write that down. 7:30 to 11:30 India time. 7:30 to 11:30 India time. Let me just bring up this world time converter.
I can be available at 6 also.
6 also,
Like
just a
if you
moment.
take first class for me.
Just a second. IST, Indian Standard Time. Okay, you're in UAE, right? Okay. Abu Dhabi. Okay, so 30. So we can have classes from, you can choose anything from 5:30 to 10:30.
Mm.
Okay,
India time or UAE time.
UAE time, UAE time. I'm giving you UAE time. It's 7:30 to
Okay.
11, 7:30
Sometimes
to.
I reach home at 5.
Mm-hmm.
So
Yeah, see, I am write down the time, India time. I am available between
mm,
7:30 to 11:30 in November. Okay, next month I'm
okay.
going back to Delhi. So if we in December we might have to change the time. I will let you know if we work on this one-to-one thing, because I will have to change the time there a little bit ahead or a little bit, early. So
Okay.
for now in November, you can be sure that I'm available between 7:30 to 11:30. Okay. From
Mm.
7:30 to 11:30 I can take a class. Okay, meaning I can start at 7:30, I can end at
Can you give
11:30.
India time?
Yeah,
Like
India
7:30, 8:30 Indian.
7:30 India time, starting from 7:30 India time to
So,
11:30 India time, I can
mm.
end the class. Okay, I start from 7:30 in India time and then I end at 11:30 India time.
So like 7:30 to 8:30 Indian time.
Yeah, Indian time. 7:30 to 8:30 one class, 8:30 to 9:30 one, 9:30 to 10:33,
Mhm.
10:30 to 11:30 fourth. Okay. So that is how it is for me right now.
So I am asking you if you give the first class to me,
That I
the
can't.
7:30 to 8:30.
That is what I'm saying you. That is what I'm telling you, trying to make you understand is that I can only give you these slots right now. Okay.
Okay, okay.
You
I
can,
need this one only.
yeah,
I need
I
to work
can, I
7:30
cannot.
to 8:30.
I cannot schedule the class from my own decision, right? I can't make that decision. The team will
Mm.
make that. They will ask you when you're available. They will ask me when I'm available. So I'm giving you these slots. From these slots, whichever one you are comfortable with in November, you can tell them that, okay, this is what I'm comfortable with, and we can schedule the
Okay.
class during that. Okay.
I will check with
You can
with
take
my parents.
7:30 to 8:30 also if it is free for me. I mean, if it is, if they're not scheduling, there was this one student who has exams right now. She has her
Hmm?
exams, I think, for this other week too. That is why I'm free in 7:30 to 8:30 slot right now. Or else I was taking her class between 7:30 to 8:30. So right
Mm.
now I'm free in 7:30 to 8:30. Let inform the academic team. Tell the Learn IVO people that I'm looking for one-to-one classes. So what are the slots available? So based on that,
Okay.
they will tell you which slots they can give you and which
I will
slots you
ask my
can.
parents also.
Yeah, yeah, ask your parents and ask them. And if it's all
Okay, sir.
organized, then we can start whenever whenever they let me know. Yeah,
Okay, sir. Thank you.
you're welcome, welcome. Anything else?
No, sir.
No, all right. Just be active in classes. What I was telling to everyone, ask doubts, be proactive in whatever you have because time will fly away very soon. Okay. We are almost
Yeah.
8 days into November. 20 days are just left for November, and then your exam would start on 8 December pre-boards. Just 1 month. So
Yes.
this whole month should be spent in solving whole of NCRT for every subject. Complete it as much as
Oh,
possible. Don't leave anything from NCRT for boards. And when you are done with NCRT in this month, then you can start with other books or past year papers. Past year papers should be preferable after NCRT and exemplar. Okay.
okay,
All
sir.
right. Okay. Let's
Sounds
okay. We
good.
have a lot of other classes. We can talk about more things. Okay. All right then.
Yes, sir.
See you in the next class.